Hey calculus kids, this is Dr. Callahan with week 15 Monday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for the warm-up. All right, I hope you guys are ready for ski season. It seems like the slopes are definitely open this weekend. Let's go ahead and take a look at the question number 1. So remember when we went over the limit for infinity, it is the same thing as if you were finding the horizontal asymptote. And so there are 3 different rules for doing that. Now remember the vertical asymptote is when you simply just take the denominator and set it equal to 0 and see what it equals once you solve for x. But the horizontal asymptote, you can either graph it and take a look at it, or you can go ahead and use the following 3 rules. We went over this briefly back in Unit 1, but there are 3 different sets. The first one is, I always like to remember, if they're exactly the same power, like cube and cube, then you simply just look at the coefficient in front of the x. So in this case, it's a -3/27, which can be reduced to 1/9. Now, the second one is that if the numerator is bigger than the denominator, like 4/2, then what's going to happen is that the horizontal asymptote does not exist. On the other hand, if the numerator is smaller than the denominator, then the horizontal asymptote is going to be y equals 0. So those are the 3 different rules that we use with this. So then with that said, if you take a look at the 3 examples here, applying that rule to the 3 here, you will have, here you have exactly the same. So the coefficient 2/3 is your asymptote. And then if the numerator is smaller than the denominator, you know it's going to be 0. And if the power is bigger than the denominator, then it is going to be does not exist. Or it could also be positive or negative infinity, because you cannot put a definitive number on infinity itself. It is also does not exist. All right. So last time I saw you guys, it was back in week 14, Tuesday, and this is what you guys actually went through. We had a calculus puzzle on how do the present dentist help the image go straight. There were 2 different examples that we went through and looked at with the graphing of these equations with the concavities and the max and min. You also had a video guided note on the textbook work. And then we also ended up the class with a poster rotation right before Thanksgiving. All right, I wanted to go over one of the questions that was on your video guided notes, which was on points of inflection, but with trig rules. And so the same thing applies. You guys know the trig rules. You know how to find the concavity with a second derivative, but I figured it might be nice to kind of go through one just so we have it. All right, so let's go ahead and take a look at this. So with this one, you're looking for the derivative, the first derivative anyways. And so with your first derivative, f prime of x, you know that derivative of sine is going to give you a cosine x, and then your derivative with the cosine is a negative sign. And so you have your first derivative. If you're going to go ahead and find the maximum, you will set them equal to 0, but we're finding the concavity. So I'm going to do the second derivative. Derivative cosine is a negative sine x. Derivative sine is a positive cosine, but there's still a negative, so negative cosine x. Now, you know your goal is to go ahead and find x, and so I'm going to set this equal to 0. Maybe move the cosine over to the right side, so that way I have a negative sine x equals a positive cosine x. Now, if you take a look at this, when will you have a negative sine x equal to a cosine x? Think about your unit circle. And in the exact spots when this happened, with a negative sign and a positive cosine, is going to be right here. And in which case your x is going to be 3 pi over 4 and x equals 7 pi over 4. If you're not sure, let's go ahead and take a look at the unit circle. Okay, so in which situation will you have a negative sine x equal to a positive cosine? So if you look at this right here, here is my negative sine x is equal to a positive cosine x, which is going to be at 3 pi over 4 and 7 pi over 4. So that's what you would get that answer, okay? And now that you have those two, we're going to go ahead and use this on the sine line to go ahead and test for concavity. So here is my sine line. Okay. That was weird. Anyways, so then on my sine line, I'm going to have my first one at 3 pi over 4, my second one at 7 pi over 4. So if you're going to go ahead and find a number that is going to be on the left side of 3 pi, excuse me, over 4, a good number to find or use is going to be pi over 2, okay? A number that's good to pick that's going to be in between these two is f double prime of pi, okay? And of course, if you feel like you're uncomfortable with 3 over 4, remember this is the same thing as saying 0.75 pi. And that's why I picked one pi on the right side and half a pi on the left side. And 7 over 4 is like 1 point something something, but it's not to 2. So if I'm picking a number on the right side of that, I probably would do, you know, f double prime of maybe like 2 pi or something. Or you could do 11 pi over 6. Okay, so then once we have that, we're going to go ahead and test it. So if you plug this back into the original equation, okay, of f double prime of x, not the original, f double prime of x, I should say. F double prime of x is going to end up with if you have a negative pi over 2, that is going to be a negative pi over 2 is going to give you a negative 1 minus cosine pi over 2 is going to give you a 0. So if I subtract that, it's going to give you a negative 1, which means that this part here is going to be a negative. Okay? And if I take a look over here, I will do the same thing, f double prime of pi. So negative sine pi is going to give you a 0. And then minus, if you do a negative cosine pi, that's going to give you a negative 1. So then double negative makes it a positive. So it'll be 0 plus 1, which is a positive 1. So in between, this part is going to be a positive. And then f double prime of 11 pi over 6. So negative sine 11 pi over 6 is going to give you a negative 1/2. But don't forget the negative that's in front of the sign. Minus cosine 11 pi over 6 is going to give you a square root of 3 over 2, set it equal to, and if you look at this, it's going to be a positive 1/2 minus a square root of 3 over 2, which means a square root of 3 over 2 is still bigger than that 1/2, so your answer is going to be a negative here. Okay, so then at this point, you can say that it is a concave down on the left side of 3 pi over 4. So that's your point of inflection. 3 pi over 4. And if you were to go ahead and find the y value, you just simply do cosine of 3 pi over 4 minus sine of 3 pi over 4, which is going to give you a value of 0. And I'm sorry, you plug that back into the original equation, not f prime of x, sorry. Back into the original equation will give you a 0. And then in between 3 pi over 4 to 7 pi over 4, you have a positive with a second derivative. So that's a concave up. And your point of inflection here is going to be 7 pi over 4. If you plug this into the original equation of f of x, you'll have a 0. And then it is going to be concave down after 7 pi over 4 to positive infinity. And so there you go, you guys. That is going to be your answer for this example. Okay, so take a look at the breakdown for today. Today we're going to talk about L'Hopital's rule, which is a second method of finding the horizontal asymptote. Okay, and yeah, let's go ahead and get started then. So here are your guided notes for today. Here is your first page, and it's just my notes typed up and written out with the horizontal asymptote. Okay, and it's the same thing as x approaches infinity or negative infinity. I do have several examples here, and then also the guidelines for finding the limits at positive or negative infinity. Second page is a continuation of the examples. You have 7 examples in all. And then also I have my 3 rules of finding the horizontal asymptote. Or 8 examples, sorry, 8 examples. All right, so with that said, let's go ahead and jump right in and get started. So 3 rules of finding the limit using the exponential method. If the numerator exponent is greater than the denominator, then the limit is infinity or negative infinity. Or you could think of it as it just does not exist, okay? We should put or does not exist. If the numerator exponent is less than or smaller than the denominator, the limit is just simply equal to 0. And lastly, if the numerator's power and the denominator's power are the same, then you are simply looking at the ratio of the coefficient, so you refer to the numbers in the front. So take a look at these 3 examples and tell me what are the horizontal asymptote. First one's pretty simple. You have the same exponent, so it's just a coefficient, 3 over 5. Second one, the numerator is smaller than the denominator, so y equals 0. Last one is a little bit trickier because you have a square root, and with that square root, you need to be a little bit more careful with it. You know that the square root of x squared is just x, so then the square root of 2x squared is just simply, you just need to break it down into a square root of 2 times the square root of x squared. So that's just going to give you a square root of 2 times square root of x squared is just x. So the coefficient is a 2. The denominator is a 3x. And if you look at the power of the denominators, they're exactly the same. So you're looking at the leading coefficient, which is a square root of 2 over 3. And it is a positive and negative because a square root of 2 is always going to end up with a positive and a negative. Because a square root is essentially talking about the distance from 0. So positive and negative. All right, so next we're going to go ahead and talk about the L'Hopital's rule of finding limits as x approaches infinity. Now, normally you can just simply look at the exponent and you should see that they're exactly the same. So your answer is just going to be 3 over 5. But how do we actually get to that point? That's where L'Hopital's rule comes in. So your first step is going to divide both the numerator and denominator by the highest power of x appearing in the fraction. So the highest power here is 2. So I'm going to go ahead and basically multiply the numerator and denominator by 1 over x squared, okay, or divide it. So it will look like this once you go ahead and distribute it through. Now, what's going to end up happening is that you know x squared and x squared cancel, so 3 is now by itself, and that's where you get the 3 right here. Your first x cancel as with the second x, you're left with an x. So we're just going to simplify it. So you're left with 5. There's your 5. One of the x's cancels out, and you're left with 1 x on the bottom. Next is that Notice that when you have a super large denominator, what generally happens? If you have a small number on top and like a very large number on the bottom, like infinity, wouldn't you agree that eventually as infinity gets bigger and bigger, you will just get to 0.00001 or 0.000 something? So essentially, it's just going to lead to zero. So what you want to do is that 5 divided by infinity, because as x approaches infinity, it's just going to become zero. 9 over infinity squared, or 0 squared, is, or sorry, infinity squared is just going to become zero. This part's going to become zero, and the second part's going to become zero as well. So then eventually you just lead with 3 over 5. And that's where the L'Hopital rules comes from, is as x approaches infinity, how do you go about just looking at the leading coefficient? Well, this actually is the mathematical portion of how you get to that point. Okay, so next let's talk about the L'Hopital's rule with the second method, okay? So what this is going to happen is that if I were to go ahead and apply x equals infinity, you'll have 3 infinity squared minus 5 times infinity plus 9, which is just like a really, really big number times 3 squared minus a really big number times 5 plus 9, which is still infinity over infinity. So the L'Hopital's rule in this case cannot be applied because it is an indeterminate form. So what we're going to do is we're going to go ahead and differentiate the numerator and differentiate the denominators. And notice how we are actually talking about infinity again for the third unit, mainly because we couldn't talk about differentiation with the first unit. So that's why I kind of held off on doing that. So if I find the derivative at the top, I have 6x minus 5, okay? And then the derivative of the denominator, it'll just be 10x plus 2. So then I'm going to take the answers with these two, put it back into the fraction, and apply the limit again. So as x approaches infinity, I will still end up with 6 times infinity minus 5, which is still a really big number. 10 times infinity minus 2 is still going to be infinity. So in this case, it is still indeterminate. So what do? We're going to go ahead and find the derivative one more time of the new numerator and denominator. Derivative of 6x minus 5 is going to give me a 6. Derivative 10x minus 2 is going to give me a 10. Now I'm going to go ahead and do 6 over 10. You can go ahead and reduce it, which ends up with 3 over 5, which is the same thing as if you're doing the horizontal asymptote rules, or if you go ahead and just simply divide it by the largest exponent. All right, so then let's go ahead and take a look at the next example. Just by using the horizontal rules, you should see that the exponent on top is a lot smaller than the bottom. So you know y is going to be 0, but then let's make sure that we can do this and we understand why we're doing this. Okay, so first thing we're going to do is let's go ahead and divide top and bottom by the biggest exponent, which is x to the 5th power. Okay, sorry about that. I had to get rid of that thing that's just driving me a little bit crazy. All right, so then I'm going to divide the numerator by x to the 5th power and divide the denominator by x to the 5th power. So I will have something that looks like this. And then as you know, you're going to try to simplify this. So you have x to the 3rd, x to the 5th. So if you go ahead and cross that out, you'll have an x squared. Same thing over here, x to the 5th. So if I cross that out, x to the 4th. And then again, down over here, that's going to cancel out to a 1. All right, so then at this point, we're going to go ahead and just apply the infinity rule. So 95 divided by negative infinity squared is going to be a 0. It's just a really, really big number, or a small number divided by a really big number, so that's going to be 0. Same thing over here, 57 divided by x to the 4th power, it's going to be 0, 0. This part's going to be 0, and then it's just 0 divided by 1, which is simply just 0. And that is your asymptote. Do the same thing over here, but this time let's try to apply the L'Hopital's rule, okay? With the L'Hopital's rule, what you're going to do is you are going to differentiate the numerator and denominator. So I'm going to split them right here. And the derivative of 95 cubed plus 57x plus 30 is going to give you 285 x squared plus 57. And the derivative of x to the fifth minus 1,000 is 5x to the fourth. Now we're going to go ahead and put them back into the limit and apply the limit with a negative infinity. And you're still going to end up with a infinity over infinity. And it's a positive because when you put a negative infinity squared, it's going to give you a positive. Negative infinity to the fourth power, which is still even, it's still going to give you a positive. So it's indeterminate again. So let's try to do it one more time. Derivative of 285 squared is going to give you 570x. And then same thing over here, 20x cubed. Let's move this up a little bit. It's still going to end up with a negative infinity over negative infinity. So now let's go ahead and find the derivative one more time. And if I do that, I'm going to have 570, 60x squared, okay? And then if I apply the negative infinity, what's going to end up happening, I have 570 on top with a 60 times negative infinity squared, which is just a positive infinity squared. It's just going to be a positive infinity. And as you have a negative or an infinity in the denominator, which is a really big number, you have a 0 in the denominator, or something that's going to lead it equal to 0.00001. Okay, so then what happens here is that because the denominator is going to be a really, really big number, your numerator essentially is just going to become 0. So the whole thing is going to be 0. All right, let's go ahead and take a look at this one here. Actually, no, I'm not going to take a look. We're going to skip this one. I would like you guys to go ahead and take a look at these 4 examples. Go ahead and give them a try. I would suggest you could probably use the 3 horizontal asymptote rules, but I would either have you try to divide by the biggest exponent or try L'Hopital's rule and see how far you get with this, and see if you have the same answer as if you were just checking this with 3 horizontal asymptote rule. Okay, here are the answers. Take a look at them for 1, 2, and 3. Example 4. For example 4, B, especially with the square root, you want to be careful with the square root because you should know that you can go ahead and, okay, this thing is, go away. This, you can go ahead and rewrite this, so that way you have 3x over, and because you have a square root of 2x squared, that's the same thing as square root of 2 times x squared of x squared, which is going to be square root of 2 times just x, okay? So then you have a square root of 2 times x, which will give you a 3 over square root of 2. Remember, the rules of algebra is that you don't want to have a square root in the denominator, so no multiply by a square root of 2 on the top and bottom. And square root of 2 times square root of 2 is just going to be a 2. And then 3 square root of 2 remains in the numerator, which is exactly what you have here. But you have a negative because it's a negative infinity. All right, you guys, at this point, I would like you guys to go ahead and read the 4 examples here. So pause the video and just take a look to see how this will work if you were to actually use a chart versus, just simply using the 3 horizontal asymptote rules. Okay, so now what I'm going to have you guys do is we're going to go ahead and watch a video with the 4 examples. And once you get to this point here, You can go ahead and pick any of the videos that you would like. There are several of them. If you need some additional practices with L'Hopital's rules, you do have them available right here. Okay, if you would like to go ahead and practice a little bit further with the quizzes, I have one right here. You just simply, and actually, you know what, I'm going to change this so that way you have a smaller URL to type in. So give me a moment and let me convert this over. Copy that, put it right over here with a tiny URL. Okay, so if you go ahead and type in the tiny URL of 3Q5WC61, you will be taken over to the quizzes right here. And you could pick whichever one you would like to go ahead and practice. I'm just gonna go ahead and pick this one right here. You're just gonna click on Start a Live Quiz Classic. And then what you're gonna do is on a separate browser, you're gonna go to joinmyquiz.com and then type in the code. Type in the code, and then you can just go ahead and start playing with this. Okay, you guys, that's basically it for today. So today, as a quick review, we talked about horizontal asymptote, the three rules of them, the limit as x approaches infinity. We talked about the first rule of finding horizontal asymptote with division of the biggest exponent, top and bottom. And then we also talked about L'Hopital's rule. So I hope you guys have a good day, and I will see you guys next time. Take care.